Let's look at wire and wire sizes. Wire can be really big, like for great big electric motors. It can be really small, and by wire I should say conductors. Conductors can be really small, like on a circuit board. And a conductor is a material that allows electrical current to flow. And think about what you know about these electrons orbiting around in their shells, and how it's the valence electrons that cause current to flow, because those shells are not full and it's easy for that electron to get knocked loose. So a conductor has a valence shell that has 1, 2, or 3 electrons in it. Later this term we'll talk about semiconductors, which have 4 electrons. And how easily current can flow through the wire, or how much resistance there is to current flowing through the wire, depends on how long it is and how big around it is and the temperature. A big wire carries more current. A small wire carries less current. A big wire has less resistance, and so it doesn't heat up as much. It's easier for electrons to move through a wire that is short and big in diameter. It's hard for electrons to move through a long, thin wire, and that will cause more heat. Those were conductors. Insulators are materials that do not allow current to flow. So they have valence shells that are full of electrons. The electrons can't get knocked loose. The National Electrical Code has a lot of specification about conductors, what they shall be. And first of all, the material must be copper or aluminum in wires and cables. And secondly, it must be insulated. The wire size is measured with a system called AWG, American Wire Gauge, and the sizes go from big wire, which is a small number, like 0 or 4 zeros. The wire sizes go from big wire, which is a small number, to small wire, which is a big number. So that's kind of confusing. Sorry about that. You can measure wire with one of these handy wire gauges, and you can pick these up all over the place at parts houses and hardware stores and online. They're kind of handy, and they measure both wire and sheet metal, because sheet metal uses a similar system. Here are some of the systems that we use for wire and sheet metal. Here's our sheet metal system. Here's our wire system. And you can see here that looking at the diameter of the wire, that a small number has a bigger wire. We talk about wire sizes as big as 4/0, 4 zeros. When we get over 4/0, then we stop using those numbers and we talk about circular mills. A mill means 1/1000th of an inch, 0.001. If a wire is 1 mil in diameter, or 1/1000th of an inch in diameter, it has an area of 1 circular mil, and that's what we use for sizing big wires. If you have a really big wire and it has 1,000 circular mils of area, we write MCM. This is an old-timey system left over from Roman numerals. In Roman numerals, the letter M represents 1,000. So old-timers and modern electricians say MCM to mean 1,000 circular mils. And as we saw earlier, more current can flow through big wire. And the amount of current that can flow is called ampacity. You'll see the electrical code talk about ampacity. think of the words amp and capacity. It's the capacity to carry current, to carry amps. The electrical code has tables showing if you have a certain number of amps, what size of wire you have to use. And it also has tables showing what size of circuit breakers you have to use. Now, as you will see in the code, if you look there, you can use one big wire or a bunch of little wires bundled together. A bunch of little wires together is called stranded wire. Those little wires are strand. And so you get a bunch of small, usually copper, all bundled together, all touching each other without insulation. Those are strands. And when we talk about the wire size, we use this system like you see on the bottom, a number slash another number. And what those numbers mean are, the first number is how many strands are there, and the second number means what AWG wire size is each one of those strands. So a 3744 has 37 strands, and each strand is a tiny little 44 gauge. The advantage to using stranded wire is that you can bend the wire more. You have a smaller bend radius. And you can probably picture that. A big, thick wire doesn't bend very easily. A bunch of little wires, little strands together, bends more easily. So that's the advantage. And when you look in manufacturers' catalog pages, you'll see that for each wire size, they list what the smallest bend radius is. We use the words wire and cable. Wire is basically a single one, and a cable is multiple ones with insulation around the bundles and then an overall covering over the bundles. In any event, the electrical code requires markings on the insulation. The insulation is called a jacket. And there are very clear code guidelines about what size it has to be and what the jacket has to be made of, and all of that has to get marked on the jacket. The code specifies what kind of material the jacket can be, depending on what kind of situation the wire is used in. So if you're in a wet location, let's say you're wiring you're in a sand and gravel pit wiring electric motors. That's a wet location and it's exposed to direct sun, so there are specific requirements for the jacket in that location, because the last thing you want is your jacket degrading and developing cracks and electric current leaking out. There are some requirements for wire color. For example, ground has to be green. But many of the wire colors are up to you, and you can order wire with a certain color of jacket, and then in your schematic or wiring diagram you can specify, you can write what color that wire is, and this is very helpful to the electrician or to someone doing the installation, or to someone coming along and troubleshooting.